Lesson 11.4, found on page 447, is a continuation of our previous lessons in this chapter. Now we're going to find the surface area of pyramids. And in this particular lesson, they're going to begin with a pyramid that has a square base like this one. They're just starting with the net instead of showing you the solid, but this is what it would look like. Okay, essential question. How can you find the surface area of a pyramid? Most people think of Egypt when they think of pyramids, but there are ancient pyramids throughout the world. The Pyramid of the Sun in Mexico was built around 100 CE and is one of the largest pyramids in the world. Kara's making a model of the Pyramid of the Sun for a history project. The base is a square with a side length of 12 inches in her model, obviously not in the real pyramid. Each triangular face has a height of 7 inches. What is the surface area of Kara's model? So how much material does she need to buy in order to make this? This model. So the base is 12 inches, meaning each of these sides is 12 inches. The height of each of the triangles is 7 inches. Okay, so label, we just did that. Find the area of the base and each triangular surface. Okay, so the base is a square. So the formula S side squared works because it's a square. But remember that you can always use area equals base times height. If you don't want to memorize more formulas for rectangular surfaces, this one will work for all parallelograms. Okay, we're going to substitute in 12 for S. So that would be 12 squared, which remember, this tells us how many power lines to write. So it's 2 power lines, and then we put the 12 on each of them, so it equals 144. So the surface area of this square is 144 inches squared. Okay, notice that base times height works exactly the same. Base times the height is 12 times 12, which equals 144. You're going to get the same answer if you use this for any parallelogram. All right, so there's our base. Now we're going to write the triangle formula for the area of a triangle. Area equals 1/2 base times height. So we substitute in 12 for the B, because that's the base of the triangle right here is 12. 7 for the height. And simplify, meaning work it out. Okay, so area equals 1/2 12 times 7, which is, let's see, what would that be? 84. Half of 84, which is 42. So the area of this one triangle is 42 inches squared. So now, in order to find the area of the whole pyramid, the surface area of the whole pyramid, we have to find the surface areas of all of these triangles, which are all 42, because they're all the same size. Otherwise, they wouldn't meet at the top, at the point, if they weren't all exactly the same all the way around. So there's a couple different ways you can do that. You can write okay, so they did do it the easier way. I'm glad to see that. Okay, so this capital S means the surface area of this whole net is, there's our base, 144 plus 4 times 42, because there's 4 triangles that are 42 inches squared. So I need to do a little margin work. 4 times 42 is 168. So that's 144. I'm just bringing that over again because I needed to solve this. And that's 168. If I add those together, again, margin work, because I don't add well horizontally. I do better vertically. 8 plus 4 is 12. Regroup the 1 in the tens place. 1 plus 6 is 7. So that's 11. 1, 2, 3. So it's 312 inches squared. So the surface area of Kara's model is 312 inches squared. So this whole thing, if she's going to make her model out of, cardboard or whatever, she needs 312 square inches of material in order to make this. All right, let's do another one. Okay, so this time we have a different kind of pyramid. We have, do I have one like that? I do not have a, well, no, I don't. Okay, sometimes you need to find the total area of the lateral faces of a solid figure, but you don't need to include the area of the base. The lateral area, L, capital L, of a solid figure is the sum of the areas of the lateral faces. So they're saying we don't care about this part. All we want to know about, all we want to discover are the lateral faces, these. For some reason, it's just going to be hollow at the bottom, like this. So there is no base. It's just lateral faces, like that. All right, so Quan is making a tent in the shape of a triangular pyramid. The 3 sides of the tent are made of fabric and the bottom will be left open. The faces have a height of 10 feet, this right here, and a base of 6 feet. What is the area of the fabric Quan needs to make this tent? All right, so find the lateral area of the triangular pyramid, draw and label a net. Okay, so we would do something like, so we're going to need some triangles for our lateral faces. I'm going to draw the base in also, just to keep me organized. Okay, so the net is going to look something like this. It has 3 sides. And let me color the sides so you can see. So this is one side. This is another side. And that's the last side. Now, the base, this base is just open. He just wants to sleep on the grass with his tent. He doesn't want a floor of the tent. Okay, so, I did that. Shade the lateral areas of the net. I did. Find the area of one of the lateral faces of the pyramid. So, this is what? 6 for the base and 10 for the height. Here's our area formula. Area equals 1/2 base times height. Substitute 6 in for B for our base and 10 for the height. So we put in that 6 and 10 into our formula. Simplify. So that's half of 60, right? Because 6 times 10 is 60. Half of that is 30. So the area of one of these triangles, just one, is 30. All right, so now 30 feet squared. So to find the lateral area of this whole tent that he's going to make, find the area of all 3 lateral faces. So they're all 30. Otherwise, they won't meet in the middle at the top. So 3 times 30 equals 90. So the area of fabric Quan needs is 90 feet squared of fabric. All right, so let's take a look at these questions at the bottom. Explain the difference between finding the surface area and the lateral area of a three-dimensional figure. So the difference is basically you're just not finding the base. So surface area includes all surfaces, includes, I should have inserted the word area. Let me put that in. Includes area of all surfaces. Surfaces include bases. Includes bases. The lateral area does not include the base. All right. Explain how you could find the amount of fabric needed if Quan decided to make a fabric base for the tent. So he doesn't want to sleep on the grass after all. He wants some fabric between him and the ground. The height of the triangular base. Quan decided to make a fabric base for the tent. Oh, I get it now. Okay, so the tent, the base of our tent is triangular, right? And they're saying this is about 5. Remember the sides were 10 feet? Well, this right here is much smaller. It's only 5. It's half as tall. Okay, so let's get back here. Explain how you could find the amount of fabric. Okay, so the base would be area equals 1/2 base times height, right? Because that's our formula for triangles. And the base is triangular. So that would be area equals 1/2 6, because the base is still 6, but the height is only 5. So 6 times, pardon me, 5. So that's 30. 6 times 5 is 30. Half of 30 is 15. So area equals 15 feet squared for our base. So how much fabric is he going to buy altogether? Well, that's going to be 90 plus 15. The 90 for the 3 sides of the tent. And that was, so the total would be 105 feet squared if he added a base. All right, let's take a look at our notes. So to find the surface area of a pyramid, use a net to find the surface area of a pyramid. So you draw the net, find the area of the base, find the area of a triangle, multiply the area of the triangle by the number of triangles, which in this case is 4, and then you add them all together. So the base is 144, one triangle is 42. Let me write that in there. So this one is 144 in the base. This is 42, each of these. And then you add, so I multiplied the 42 times 4, because there's 4 of them. Add them together, you get 312 inches squared. The one other thing we'll add to our notes is lateral area does not include the base. It is only the lateral faces, and also lateral area is written as a capital L. All right, good luck.